Okay, so in this video, we're going to continue looking at these calculations of pH. This is just taking us through water. Notice that if my pH is a 2, therefore I can do some calculations to find out what my concentration of hydronium is. I could find out what my concentration of hydroxide is. I could even find out something called a pOH that we're going to talk about in a few minutes. So if my pH is 2, to find the concentration of hydronium, the opposite of a log is 10 to the negative. So what I would do is I would take 10 to the negative pH, or 10 to the negative 2, and that's going to be my concentration of my hydronium. So therefore, my concentration of hydronium is going to be 1 times 10 to the negative 2. Well, I know that Kw equals hydronium times hydroxide. I know that my hydronium is 1 times 10 to the negative 4. I'm going to plug in this 1 times 10 to the negative 2. I'm sorry, 1 to the negative 14th is Kw. I misspoke. I'm going to put in my hydronium, which is 1 times 10 to the negative 2, and I will find out that my hydroxide ion concentration is 1 times 10 to the negative 12. So all of these things are all interrelated, and you can mathematically go from one thing that you know to the next. Okay, just some practice questions. Think about them and pause it. This pH is going to be 10. Good. Okay, let's look at this thing called pOH. If pH was the power of hydronium ion, I hope you're thinking pOH is the power of the hydroxide ion. So just like pH, pOH is the negative log of the hydroxide ion. So if the hydroxide ion is 1 times 10 to the negative 9th, you take the negative log of that concentration, you're going to find that the pOH is 9. Here are a couple other examples. All right, so pOH of 1 times 10 to the negative 10, pOH is, that's right, 10. So there's a relationship then between pH and pOH because of this Kw, this self-ionization of water. Because Kw equals 1 times 10 to the negative 14th, and these concentrations are related, therefore the pH plus the pOH always equals 14. So now if I know a concentration of hydronium, I can find the pH. I could find the concentration of hydroxide. If I know the pH, I can find the pOH by subtracting the pH from 14. If I know the hydroxide ion concentration, I can find the pOH as well. So all of these are intertwined. Okay, so I'm not sure. Okay, so I'm sorry if my webcam isn't ever going to pick up, and if it does, I'm just not seeing it. It's okay, let's get through this. So if I have a pH of 5, therefore I can find that the concentration of hydronium is 10 to the negative pH, 10 to the negative 5th, or 1 times 10 to the negative 5th. I can also find that the hydroxide ion concentration was 1 times 10 to the negative 14th divided by 1 times 10 to the negative 5th, or 1 times 10 to the negative 9th. From here, I could take the negative log of this, and I'd find that my pOH was 9. However, I could have just gone 14 minus 5 and gotten a pOH of 9. So you can go kind of almost any direction in a circle and find out these values. So let's try this. If the pH equals 2, the pOH equals 12. 14 minus 2, 12. What about if the pH is 10? pOH is 4. So you're going to have some practice with this interrelatedness, just like you see on this diagram here. So to get from pH to pOH, we're using the relationship that pH plus pOH equals 14. Plug in the one you know, use algebra to find the one you don't. To get from hydronium to hydroxide, we're using that Kw value, right? Hydronium times hydroxide concentrations equals 1 times 10 to the negative 14th. To get between pH and concentration, you're using either the negative log to go to pH or 10 to the negative pH to find your concentration. Likewise, you're doing that with your OHs as well. And this is the screen that's going to help you tremendously on today's assignment. So this is where I'm going to kick you loose to go do your assignment. Get really good at these calculations because these are the ones that are going to come in very important as we continue this chapter. Hope you guys have a great day. Bye.